Hello everybody, I will start my today with another live coding session. So in my today's video, I will solve this question, my calendar number 2. So in this question, I am implementing a program to use as my calendar. We can add a new event if adding the event will not cause triple booking. A triple booking happens when 3 events have some non-empty intersection. The moment is common to all the 3 events. Okay, so double booking is allowed, but triple booking is not allowed. So in that case, I can't add the new event. The event can be represented as a pair of integer starting time and end time that represents booking on the half of interval, start time and time. Okay, the range of real numbers x, such as started time and x less than end time. Okay, so for example, real integer number x represents start time and time, like 1.5 or 2 or -2. And if the start time end time is 3, it begins with 2 yeah, timestamp 2. So at time 2, there is one booking. But at time 3, because this is half open interval, I can say at time 3, there's no booking. And obviously at time 2.5, I have the booking. Yeah. And I will implement the my calendar 2 class. My calendar 2 initializes the calendar object. Boolean book method returns true if the event can be added to the calendar successfully without causing a triple booking. Otherwise, return false and do not add the event to the calendar. Okay. So in this question, I will implement the my calendar class. And for the constructor, there's nothing to be given as the argument. But for the book method, I will be given start time integer and end time integer, and I will return boolean. Yep. Which represent if I can add the event. Which means that if the new event doesn't cause the triple booking. Yeah. And also in the book method, this mutates the calendar. So if the calendar can be added, if the given event can be added to the calendar, the internal state of the calendar changes. So that new event should be saved in the calendar. But actually, all I have to do is just return the boolean. I have to be able to check if there is a triple booking or not. Yeah, so that's the thing. Okay, so so far I could understand this question. Looks good to me. And I can say start time. I mean, end time is always larger than the start time. And aside from that, start time and time is real number. Good. So let me think with an example. So firstly, I will do I will initiate the calendar like this. Then I try to book something like 1-3. Then I will return true because it's still bookable. But when I try this 3 times, on the third attempt, I cannot book anymore. Yeah. And let's say I will try that another event, 3 to 5. Because 3 is not included in the event time window. And with this one, in line 7, 3 is now included in the event time window, but not 5. So this becomes 2, and true, and then it becomes false. That's basically what I would do. And obviously, if I try to book like 2, 4, this should return false because timestamp 2 has already 2 bookings by 1 to 3 and 1 to 3. So 2, 4 should return false. Okay, so that's basically what I would do. So first, the brute force approach. What I can do is I will try to have all the events, because this is the brute force approach. I don't sort the event. Just keep track of every event like this. And every time I have a new event, I will compare with each of these events. And for example, on my third call 1-3, I will check with this. And I find that there is a interrupt, intersection. So there is one booking duplicating. And also here, I can find that this is also duplicated with the new event 1 to 3. So now it has 2 duplicated bookings, which means that I have the triple bookings if I add 1, 3, one more. So I will return false. And once I confirm that there's no triple booking, which means that there is 0 or 1 event which has intersection, I can return true. And also I will append this 1, 3 to the event list. So this is the brute force approach. And the time complexity should be O of n, assuming that there are n events included so far. So yeah. I will try to optimize this. I think what I can do is sort the events. So for example, if I have the event like 1 to 3, 1 to 3, then when I have 1 to 3 event, I need to take care how many events there are in this range. Yeah. And for example, if I get say 2 to 4, like this, I mean 1, 3, 1, 3, 2, 4. In this case, I have the triple booking in 2 to 3, so I will return false and I will remove, or I should say, I don't register this event. Yeah. So that's how I can, find the intervals. And the problem is, how can I speed up? So I don't wanna, compare each of them with a new event 2, 4. Yeah. So I think what I can do is creating the, sorry, creating the list of events. Like, for example, here, one new event is added at timestamp 1. Then at timestamp 2, there is new event added. So when I trace these from here, what I find is that at timestamp 1, the number of events existing becomes 0 to 1, then 1 to 2, and at timestamp 2, it becomes 2 to 3. And at time 3, I decrement the number of events. So at time 3, it becomes 2 and then 1. And then timestamp 4, it becomes 0. So this kind of line sweep can be used in this question. But even that being said, I think this still takes O of n time, or in the worst case, it should take O of n log n, because firstly I have to sort all the, you know, timestamps. There are 2n timestamp for beginning or ending. I have to sort them first, then I have to traverse, linear scan each event. So this is not sufficient. Actually, it works. Or maybe I can have all of them as a sorted set. So with sorted rest. So with the sorted rest, including the event or inserting the new event takes only the log n time. But so the problem is that, say, when I have the event which begins from the beginning and the ending, I have to count how many events there are by traversing beginning from the ending. So it takes log n time, over n time. So it should take over n time. Yeah. I think it seems like just keeping track of all the events should be the best and most simple solution. I think. Yeah. Yep. So let me go with that. And actually, overwhelm time is the best achievable time compressed. No, it doesn't have to over. It isn't always the best conceivabilizing. Anyway. Mm. Or maybe I can use the segment tree to keep track of the, because start and end are, yeah, they're not integers, but basically I can use this segment tree. No, I can't, because when I use the segment tree, each start and end time must be the integer. Okay, so that being said, I will implement the brute force approach. So sorry, the first approach. Yep. This is a space complexity, because if I can, register in total finally an event, then the space complexity should be O and final. Each event is stored in the event list. Okay. Wait, does it really work? Let me just confirm. So if the new event doesn't have the triple booking, it doesn't cause the triple booking, right? Ah, yeah, I think this works. And I will implement the has triple booking method. For each event, start and end time, I will confirm if there is an overlap with new new end. So let me quickly write the chart here. I will see if there are duplicate here. Yeah, so what I can do is the condition that there isn't double booking. So sorry, there isn't. I mean, the intersection is that news like this. In this case, there isn't overlapping. So this is the case when this case. But this can be this. Yeah, because and is not inclusive, it's exclusive. So even in this case, there's no intersection. Or other case that there isn't any intersection is that like this. Again, because new end is now exclusive, new end is equal to start. In this case, there isn't intersection. Yeah, so it looks like this. Okay, so in these cases, there is no intersection. So there is an intersection in the case when this. Okay. So I can say not A or B is equal to not A and not B, but looks quite confusing. So I just follow this. I don't want to mess up here. Maybe I can update it later, but I think this is good enough. So Wait, if there is an intersection, I update the dupe count. No, this doesn't work because, for example, in this case, like the duplicated event or this and this, sorry. Yeah, simply in this case, this is not the turbo booking. Dupe count is now 1 plus 2 is, sorry, dupe count is now 1 and 2. But this and this are not overlapping each other. So yeah, this is not turbo booking. This approach doesn't work. If I try to do that, I have to count the current duplicated count or booking count for each section. Then I have to increment. I see. But this doesn't work. I will think of another approach. So yeah, one possible approach is that every time I add a new event, I split the segment like this. And this has now one duplicate, and this has now two duplicate, and something like that. And still, this has two duplicated, duplicate, something like that. Yeah. But I think this isn't so efficient, I think. Yeah, maybe this works by holding this in the sorted list. Every time I have a new event, I find out the, last start and next end. Yeah. Then I split this into smaller chunk segment. Then now it works like, this. Yeah. Then, yeah, I update the count here, 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 here. So theoretically, it takes all over again time to find each you know, this and this segment, and then splitting into two, which takes all of log n time because I just have to remove this segment and insert this and this segment. And for here, I will remove this segment and insert this and this segment. Then I increment from here to here. So accessing here takes log n time, and then I have to update each of the, segment corresponding count under here. So it takes, in the worst case, O of n time, because I have to update all the existing event. For example, if the new event is overlapping all of them. So this takes O of n time. And for space, this should be O of. This is also number of events because, for each event represents the start and end of each event becomes a, as I say, splitting point of the segment. So number of segment is exactly 2n. So space complexity should be O of n of the sorted set. So the rest. No, sorted set. Yeah. So I think, but I have one more better approach here. So I think I can look back this idea. So when I hold each event in the sorted set or sorted list, then I add a new event, then I traverse all of them. In this way, it takes O of n time. So time complexity should be O of n. Sorry, so I would say when I try to add a new event, I insert start event and end event into the sorted list. Yeah, so it takes log n plus log n is log n. Then I don't have to sort it. It already sorted. So I traverse each event and take a look how many events there are in each timestamp, or I should say in each segment. Then I will check if there are triple booking. I would return false and remove the added start and end. But if there aren't triple bookings, I just let it be and return true. So the time complexity should be O of n. And for space complexity, it should be O of n. Yes, because there are 2 times n event. Each event creates new start and event and end event. There are 2 times n, which is O of n space events in the list. Okay, so let me go with this. So let me quickly sort out the process. First, I initiate this. And for each event, append add to event list, then do line sweep, and if there are 3 concurrent bookings, then rollback. Rebut event list and return false. Otherwise, let the event list be and return true. Okay. So this is it. Okay, so now let me implement this. So firstly, I initiate the init. So I would say event. And this should have timestamp and event count diff. And for book method, I don't know what's the method of sorted with to add a new event, but let me say add. I will fix this if this is wrong. And now this is sorted, so I don't have to sort this anymore. So what I will do is count the number of duplicate events bookings. In this case, I will return false, and also I will revert the event I added. Okay. Otherwise, it will return true. Okay, so now my task is to implement house turbo booking method. So basically, I traverse each event, but I just have to take care of a few things. The first thing is that start is inclusive and end is exclusive. That's one thing. And also, let me write it down. And note number 2, what is it? Yeah. So there may be multiple events at the same timestamp. For example, it is possible that there are 2 events which begins from the timestamp 2, and there are 3 events which ends at timestamp 3. No, timestamp 2. Like this. So in this case, what I should do is taking right this timestamp, I should remove the first 2 events. Let me do it here this way. I will remove the first 2 events and add, latter 3 events. And I don't know how many events there are aside from this. Probably there are, which is ongoing. But the diff here, it should be -1 plus 3 is +1. So at this timestamp, I don't know how many events there are, but I can say there 1 event increase. That's what I can say. So let me think of this in the real example. Oh, I sort by timestamp and then diff. So the good thing is that because the list is sorted, it sorry, this should be a timestamp. The events are sorted in this way at timestamp 2. No, -1 is first. So if I just track them in this order, the diff should be -1, -2, -1, 0, +1. So at here, right here, number of events is actually smaller than the current number of events, ongoing number of events, actual one. But it's okay because my concern is if the number of concurrent events exceed 3 or not. So if the number of events at here or here, I don't know, here is less than the actual number, it's fine. I'm just interested in here after traversing all the events at the same timestamp. Here, the total depth is +1. So here, this is equal to actual number of events. So I can check it here. And at least if this doesn't have the triple booking, I can say there isn't, any triple booking in while traversing this. Okay, so total race works. And I can think of this simply. Traversing is fine. That's what I can say. Okay, so this is it. So I update the current count, and each diff should be applied to the current count. And if it reaches 3, I should immediately return false because there's a triple booking. And otherwise, I should continue. And if I reach the end of the traverser, probably the current count should be 0. And definitely it's 0, and I return true. Okay, so this is it. Good. So let me walk through my code quickly. I will think of the very simple example because I don't have so much time, like this. And if I have more time, I will check this again. And this should be false, false. Oh, sorry, this can be bookable. True, true, false is expected. Okay. So firstly, when sorry. Initiates my calendar here, this has the event sorted list, right? And when I call the first book method here, 2, 4 is start and end. So events add 2 plus 1 and 4 negative 1. Yes, these are added. Now in line 107, I will check if there's a triple booking on this event. So I go here. Let me separate. So here, when this is given, this is too big here. I will just read this line. Okay. So current count begins with 0. And for event, firstly 2 plus 1. Current count is now 0 plus 1 is 1. And the current count is now 3, so I go back to the 126. And then the next event, it should be 4 negative 1. So diff is now negative 1, so current count becomes 0. Yep. And current count is now 3, so I go to line 130, and assertion is met. Then I return true. Okay. So this is not true here in line 111. No, it should be reversed. It should be now false. Okay. So house turbo booking is now false. I go to line 116 and I return true. No rollback. Good. So this is okay. Now next, 1-3. I will go for real quick. I will add 1 plus 1 and 3 minus 1. This is sorted list, so this is sorted. Then in line 111, I call the has turbo breaking method with these events. And current count begins with 0. And because I already checked this method, I will go for real quick. It becomes 0 and then 1 and then 2 and then negative 1 by adding negative 1 and then adding negative 1, this becomes 0. So now there wasn't 3, so I finish iteration and reach line 130 and current count is indeed 0. And I return false. Okay, so this is false again. So no rollback and I return true. This passed. And the thing becomes interesting here when I add 1-3 event. Now event looks like this. Yep. So here in line 111, I go to the has turbo breaking method. And now this becomes 0, 1, 2, 3. So current count becomes 3. So here in line 128, this becomes true. So I return true. So in line 111, this is true. So I have to remove the event I've just added. The 1 plus 1 is now deleted. Also, 3 negative 1 is deleted. So seems like the event, so they said is completely rolled back and then return false. This is good. And internal state changes also as expected. Okay, so now I'm pretty confident in my code. So I submitted. Okay, event is not, oh, this should be the instance variable. Good. Okay, accepted. So I execute my code again. Great, accepted. Okay, so let me quickly wrap up my today's coding practice. So today I solved the question, my calendar number 2. So in this question, I implement the calendar class. And the calendar class, I can add the new event. But if the new event causes a turbo booking, that event is not added and just return false. If it doesn't cause the turbo booking, the event is added and it returns true. So this is my calendar class I will implement. And I thought of a few approaches. And brute force approach, I firstly came up, looked good, but actually it didn't work because number of maximum concurrent bookings is not equal to the number of events, which is duplicated or overlapping with new event, like this example. So this event didn't work. This approach didn't work. So I thought of a few other example approaches, and this approach is another one I came up. So I basically keep track of the number of concurrent events for each segment, each time segment, and when new event is added, number of segment may increase. But this implementation will be so complicated. So I use another approach, line sweep. So I, kept track of all the event in a sorted order. Event means that the tuple or timestamp and event count diff. And because this is sorted, I just had to line sweep, reverse this array from the beginning and count number of events for each time stamp. And the approach is that I quickly firstly add the new event to this sorted list. And if there is a turbo booking, I revert the change, new event, and then I return false. But there's no turbo booking. If I find that there's no turbo booking by doing the right sweep, I just return true and no rollback. So this completely worked. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye. No. I didn't stop my recording. Bye.